Okay, so let's go ahead and finish the notes here. We've got 2 more pages to complete. Let's start off with this problem. It says here that a truck pulls a caravan at 85 kilometers per hour south. When they hit a bump in the road and the caravan detaches, if the caravan decelerates at a rate of 1.3 meters per second squared north along the road, how far will it travel before it stops? I'm going to come over here and look at the side note. It says here, how can you show that velocity and acceleration are in opposite directions? Well, to do that, you can do that by having your velocity set up as a positive and your acceleration set up as a negative value, meaning that they're opposite there, positive and negative. That's how you're able to set that up. Don't forget directions. North is a positive, east is a positive, south and west are both negative values. Again, though, that's directions. We like to use words, but there are times where we will see the negative values, and that's what it tells me, direction. But for acceleration, if it's a negative value, it tells me that it's slowing down. That's what a negative answer tells me, not the direction. I still need to write the direction. So let's go ahead and set up this problem. Well, first thing is, this is a new set of notes that I've never used before, and I do not like how they had 2 different sets of units there, and both of them have combined units. So let me convert this number for you to 23.61 meters per second. Okay, so now with that information, let's label. This would be my VI. It comes to a stop, my VF. Here is my acceleration. They want to know how far, question mark, distance or displacement. That is step 1. Step 2 is to label all of your variables. VI, VF, T, D, and A. Let's fill them in. 23.61, 0, not given to me, question mark, 1.3. Here we go. Now with this information, let's go ahead and use our flow chart since we can use it with us at this point. They would like to know, was displacement ever used or talked about? Yes, that's the variable I'm looking for. Now they want to know, was time ever discussed or given to it? Nope, sure was not. This is the equation they would prefer us to use. Okay, so we could use that equation there. That's the route it gave me. Let me write that in. The equation is A equals VF squared minus VI squared over 2D. I know I mentioned this on Friday that this can actually be put into the triangle to help cut back on algebra. Here we go. Cover up the equals. All of this is together at the top, so it has to go at the top of my triangle. This is all at the bottom, so 2 and D. Now I can plug in the A. What variable am I looking for? The D. Cover that up. 2D equals VF squared minus VI squared over A. Now my algebra is set up for me. All I need to do is plug in my numbers. Let's do that. 2D equals 0 squared minus 23.61 divided by a negative. This says decelerates, so this is really a negative number, 1.3. This 0 has nothing, it's not going to do anything. But look at this, negative and negative. They're going to cancel each other out and have a positive, which I love. But look what I forgot to do. I forgot to bring this square down. So don't forget to bring this square down. 23.61 square actually comes out to 557.43. Please go back and double check my math. All right, you never know. Now I'm going to go ahead and get those two numbers and divide them. But don't forget, negative and negative is going to cancel each other out. So 2D equals 428.79. Divide by 2. The distance, or the displacement, comes out to 214.40 meters along the road. There we go. So we got that problem done. Let's go ahead and look at the next one down here. The next problem says that a car accelerates through a 85-meter stretch of road. Distance. Reaching the velocity of VF east. If it took 6.3 seconds t, what was the car's acceleration? Question mark A. So I did step 1 by underlining and identifying the variables. Now I'm going to do step 2, which is list everything on this problem. So start off with all of the variables. List them all. VI, VF, T, D, and A. VF is 27. The distance was 85. 6.3 seconds is the time. A is my question mark. They did not give me VI. Here's what I need us to do. Please do not assume that it's automatically going to start from 0, the VI. I don't know if that's where they're analyzing from the beginning, from 0 all the way to this location or this time. I don't know. So don't assume that. Now let's first go back and look at our flow chart. Was displacement or distance ever given to us? Yes, it was. Next question is, was time ever given to us? Yes, it was. So here's my equation they gave me. D equals VI times T plus 1/2 AT squared. That's the route they want us to go. D equals VI times T plus 1/2 AT squared. Now let's look at what we do have, or what was given to us. We do not have a VI. That's not good, because in our notes it says you must have a VI. VF was given, but I don't need it. T was given, okay, good. The D was given, and the A is missing. I am unable to use this equation because I'm missing 2 variables. Let me go back on my flow chart. Could I use this equation instead? Let's look. A is what I'm looking for. VF was given to me, but I don't have a VI. The 2 is a given, and the distance I do have. So that means I'm missing 2 variables again. Could I solve for the VI or the A? Well, let's come over here. T, VF, I'm missing VI and A. I cannot even use this to plug in to help me answer this. This is a really good problem. Unfortunately, we only had 55 minutes, and actually we only used about 30 minutes in class to do the notes. So I did not get to talk about this in class. This good situation here. When, and let me go ahead and write this into our notes. There we go. When VI and A are both not given, still use this equation, because again, that's the one that our flow chart sent us to, from flow chart, but change the VI to a VF, because we do have the VF, but if you make that change, then you're going to have to make another change and change positive to a negative, or the plus sign to a subtraction sign. So let me go ahead and rewrite the actual equation we're going to use now. D equals VF parentheses T minus 1/2 AT squared. That is the equation we're going to use now, so we can go ahead and solve for this. Let's plug in what we do have and use our algebra skills here. 85 equals 27 parentheses 6.3 parentheses subtract 0.5 A parentheses 6.3 square. Don't forget to square that 6.3. I did that first and I got this number of 39.69. Okay, now let's go ahead and use our algebra skills. What I would do first is multiply those two numbers, and I would go ahead and multiply those two numbers. So let's do that and bring it down. 85 equals 107. I'm sorry, 170.1. Minus 19.85A. So all I did was multiply those two numbers. That's what I got. Multiply those two numbers, and that's what I got. The A is still with it. Now, hopefully you see that this number and this number, let's look at it this way. If I put a plus here, that's a negative. Now I can go ahead and see that and subtract 170.1. Subtract 170.1. I end up with a negative value of an 85.1 equals a negative 19.85A. Yes, you are going to get a negative value here. Please do not put 170.1 into the calculator first and then subtract the 85. No, do it in the order that you see it. Just like that. Yes, I have a negative. That's okay. I'm telling you, your algebra should be amazing, and then you're going to see how everything works out perfectly. You still need to solve for A. So to do that, let's go ahead and divide 19.85. This cancels, divide a negative 19.85. A comes out to 4.29 meters per second square. East. There we go. So that was a really good problem to work out together. That way we saw what happens if we get this situation, even though our flow chart sent us here. That's how awesome our flow chart is. It knows where to send us. And even though we had this problem here with the VI, we can go ahead and flip it to the VF, but yet we had to flip and change the plus to a negative subtraction. Okay, let's go ahead and go to the last page. It looks like this. Let's start with the top problem. A police cruiser is on patrol moving 53 kilometers per hour west. When it receives a notice of an emergency, it quickly accelerates to 94 kilometers per hour west over a distance of 73 meters. Determine the acceleration of the police car in meters per second. Well, They want you to find it in meters per second. Again, I'm very sorry. They should not have gave it to you in kilometers per hour. I would have not have done that. Let me change that. The conversion is actually 14.72. Oops, that's a 1. This conversion comes out to 26.1. There we go. Now let's go ahead and do step number 1. Step 1 is to go ahead, identify all the variables and numbers you have. This is my VI. This is my, right here, VF. Determine the acceleration. This is my distance over here. And let's go ahead and do step 2, which is list everything out. VI, VF, T, D, and A. VI is 14.72, 26.1. T, never even given, 73, question mark. Okay, well, before I go any further, I'm going to go ahead and go back to my notes and look at the flow chart. Was displacement or distance ever utilized or talked about? Yes, it was. Was time ever discussed or talked about? No, it was not. This is the equation you're going to use. And guess what? You need a VI and a VF. They gave me both of those values, so we are looking good. A equals VF squared minus VI squared over 2D. I'm looking for, check, I have it, check, I have it, check, and check. Oh, this is awesome. A equals 26.1 squared minus 14.72 squared over 2 times 73. So let's go ahead and simplify this a little bit more. A equals 681.21, subtract 216.63 over 146. Let's go ahead and I'm going to do the top part, the subtraction. A equals 464.53 over 146. A equals 3.18. Double check my math. Meters per second square west. There we go. That was not too bad. Let's look at the next one, or the last one here. There's a fire truck is also on its way to the emergency. The fire truck accelerates. Here's my acceleration number, A, east for 37 seconds, T. From rest, VI equals 0. How far, question mark D, did that actual fire truck travel? Okay, step 1 is done. Step 2, let's list VI, VF, T, D, A. VI is 0 because it's from rest. VF they never gave me, but T was 37. The distance is my question. A is 0.75. Step 3. Right now, since we can use the flow chart, let's use it. Was D ever given to you? Well, yes, it was. It's my unknown, but yes. Was T ever discussed or given to you? Yes, it was. So this is the route that they want you to go on the flow chart. They want you to use this equation right here. So let's go ahead and let's plug that in. D equals VI parentheses T plus 1/2 AT squared. Yes. Give me a moment. Okay, so let's go ahead and let's fill in the blanks. D is what I'm looking for. 0 times 37 parentheses plus, I'm going to change 1/2 to a 0.5 times 0.75 37, don't forget to square the 37. Anything times 0 is 0 plus 0. Well, then forget that. We don't need that at all. I'm going to simplify and multiply my numbers. Before I do that, don't forget to go ahead and change this. When you multiply or square that, it's 1369. Multiply the three numbers together, 513.38 meters for displacement east. All right, that was the last problem done. Though we have 4 pages of notes that we're going to attach to the back of your notes, which will be part of your grade. Hopefully this helped out a little bit more. We have a quiz on Monday or Tuesday if you're a Tuesday class person. We will go ahead and work on this together in class before we take the quiz. We'll go over the homework before we take the quiz. And if there's any other questions, you let me know before we take the quiz. And then you have the quiz. You do not have to memorize the equations. They are on there. The only one that you do kind of have to memorize it's kind of rare to see this, but just in case, if this is the equation you're going to use and they gave you a VF instead of a VI, change the VI to the VF, change the addition to a subtraction, and then you're good to go. Other than that, I'll see you on Monday or Tuesday.